So in this, we are going to solve this question. So here we have nothing but expand the following function in ascending powers of x with remainder in Lagrange and Cauchy forms. So we are trying to find the expansion in Lagrange forms and Cauchy form. Okay, so number one is sine x, so that I'm giving as your homework. So please student, you try by yourself. I'm going to do for you log of 1 plus x. So you take fx to be equal to log of 1 plus x, so you differentiate this. Okay, so if you differentiate log, we get nothing but 1 by 1 plus x, 1 by x, because differentiation of log x is nothing but 1 by x. So if I differentiate this quantity, I get nothing but log, this differentiation of this is nothing but 1 by 1 plus x, and you have to differentiate again this. So differentiation of 1 will be 0 and differentiation of x will be 1, so that will be nothing but 1. So we get here 1 by 1 plus x. So this can be written as 1 plus x to the power minus 1. Again, you differentiate this quantity, so we have the formula differentiation of n, differentiation of x to the power n is nothing but nxn minus 1. So using this formula here, we get here minus 1, 1 plus x minus 1 minus 1, that is nothing but minus 2, and we have to differentiate this, so we get nothing but 1. So again, we try to differentiate this, so we have minus 1, this minus 2 will come here, 1 plus x to the power minus 2 minus 1, so that will be minus 3. So again, if we differentiate here, we get minus 1, minus 2, minus 3, and this 1 plus x to the power minus 3 minus 1, that is nothing but minus 4. So if we try to generalize this, so if you have here, when you check here, if it is 2, we have only minus 1. If it is 3, we have still minus 1, minus 2. So if it is 4, we have minus 1, minus 2, minus 3. So if it is n, x, then we'll have here minus 1, minus 2, minus 3. Here if it is 4, it is 3, so it will be minus n minus 1. So we have here minus n minus 1. And if you compare here, so this, when it is 2, this is 2, here also we have 2. If it is 3, we have minus 3. If it is 4, we have minus 4. So if it is n, we will have minus n. So we have 1 plus x to the power minus n. So if we count here the number of minus here, it is nothing but it will be n of n minus 1 terms. So we have minus 1 to the power n minus 1. And this is nothing but 1 into 2 into 3 into dot 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 till n minus 1. So this is nothing but n minus 1 factorial. So you can write here n minus 1 factorial. Since the power is minus, if I bring down, it will become positive. So we have 1 plus x to the power n. Now we try to express this function in form of Lagrange remainder. We're writing this as the Maclaurin theorem in Lagrange form. So we have fx equal to f of 0 plus x f dash 0 plus x squared by 2 factorial f double dash 0 plus so on xn by n factorial fn theta x 0 is less than theta is less than 1. So here fx is nothing but fx is log 1 plus x. F of 0 means you put here in place of x you put 0, we get nothing but log 1. So I'm putting here log 1 x. So if I put here 0, so I get nothing but 1 by 1 plus 0. So we have here 1 by 1 plus 0, x squared by 2 factorial. Then if I put here 0, so I get nothing but minus 1, 1 plus x, 1 by 1 plus 0, plus so on till here. Then we have the last term, this is the nth term. So in place of x we put theta x. So we have minus 1 to the power n minus 1, n minus 1 factorial, xn by n factorial. So we have here minus 1 to the power n minus 1, n minus 1 factorial, 1 plus theta x to the power n. So that is nothing but the expansion of Lagrange form in Lagrange form. So here if you simplify this, so we get here x plus x squared by 2 factorial minus 1 plus dot plus x to the power n factorial. Okay, x to the power n by n minus 1 to the power n minus 1 by 1 plus theta x to the power n. So we have here x minus x squared by 2 plus dot plus minus 1 to the power n minus 1 x to the power n and 1 plus theta x to the power n, where 0 is less than theta is less than 1. So this is the expansion of log 1 plus x in Lagrange form. So now we try to write the expansion of log 1 plus x in Cauchy form. So this is the Maclaurin theorem in Cauchy form. Fx equal to f0 plus x f dash 0 plus x squared by 2 factorial f double dash 0 plus so on, plus x to the power n minus 1 by n minus 1 factorial f of n minus 1 0, plus xn 1 minus theta to the power n minus 1 n minus 1 factorial f on theta x. So fx is log 1 plus x, f of 0 you know, if we get log 1 plus x 1 by 1 plus 0 plus x squared by 2 factorial minus 1 1 by 1 plus 0 whole thing square plus so on, plus x to the power n minus 1 n minus 1 factorial minus 1 to the power n minus 1. Here we get nothing but n minus 1 to factorial 1 plus 0 to the power n minus 1 plus, if we put in place here we have xn, so we put here xn 1 minus theta to the power n minus 1 n minus 1 factorial. Now in place of, we have already find f on fnx, so here is fnx. So in place of x we are going to put here theta x, so we get here as minus 1 to the power n minus 1 factorial 1 plus theta x to the power n. So here we get x minus x squared by 2, and in the similar manner, so if we get here plus minus 1 to the power n minus 2 x to the power n minus 1 n minus 1 plus, so if we check here we have this quantity n minus 1 factorial and n minus 1 factorial will be cancelled, n minus 1 factorial and n minus 1 factorial will be cancelled, so we have left with x minus 1 to the power n minus 1, so I'm writing minus 1 to the power n minus 1 x to the power n 1 minus theta n minus 1, so 1 minus theta to the power n minus 1 divided with 1 plus theta x to the power n. So this is nothing but the expansion of log 1 plus x in Cauchy form. So similar, we can also find the find here in next question we are going to find the Cauchy remainder after n terms in the expansion of this and the expansion of this in powers of x. So if I take fx equal to 1 plus x to the power m, so you differentiate this, so we have m 1 plus x to the power m minus 1. If we differentiate again, we have m into m minus 1 1 plus x to the power m minus 2. So if we differentiate this, we have m minus 1 m minus 2 1 plus x to the power m minus 2 minus 1, that is nothing but m minus 3. So we have here next is what, f and x equal to, if I differentiate n times, so if we compare from here, when it is 3 we have to go till 2, when it is 2 we have to go till 1, so if it is n then we have to go till m minus 1. So here we'll have here, this will be m into m minus 1 m minus 2 m minus 3 till m minus n minus 1. Since it is n, so it will be n minus 1. And if you check here, this power, when it is 1 here it is m minus 1, when it is 2 here is m minus 2, when it is 3 it is m minus 3. So if it is n then it will be m minus n. So we have here 1 plus x to the power m minus n. Now we have to find the remainder in Cauchy form. So this is the remainder in Cauchy form. So we're writing here x to the power n 1 minus theta to the power n minus 1 n minus 1 factorial f n theta x. So you put this x to the power n 1 minus theta and this n minus 1 factorial. Now f n theta x. So here we, in place of x we put theta x. So if we put here theta x, we are going, so we have here m minus 1 m minus 2 m minus 3 this m minus n plus 1 minus minus we get plus m minus n plus 1. In place of x we put theta x, so 1 plus theta x to the power m minus n. So that is nothing but the remainder in Cauchy form. So for the next question we'll take fx equal to log x plus 1. So you differentiate this, f dash x equal to 1 by 1 plus x, which can be written as 1 plus x to the power minus 1. Again you differentiate this, so we get minus 1 1 plus x to the power minus 2. If you differentiate again this, we get minus 1 minus 2 into 1 to the 1 plus x to the power minus 3. If you differentiate again this, we get here minus 1 minus 2 minus 3 1 plus x to the power minus 4. So if you want to express in general form, so if it here, if it is 4 we have till 3, so you write till n minus 1. So we have minus 1 minus 2 minus 3 till minus n minus 1. And if you compare, here we have 4, here also we have 4, so this would be 1 plus x to the power minus n. So if I take minus together, so we get minus 1 to the power n minus 1. Here is 1 into 2 into 3 till n minus 1. That is nothing but n minus 1 factorial. So we have here n minus 1 factorial. So here is minus n. So if we bring this one down, we get nothing but 1 plus x to the power n. Now we try to write the remainder in Cauchy form. So this is the remainder formula in Cauchy form. So we have this. This we are writing back again, and fn theta x. So in place of x, you put theta x. So here we'll put theta x. So we get this. So n minus 1 factorial, n minus 1 factorial will be cancelled. So we get minus 1 to the power n minus 1, x to the power n, 1 minus theta to the power n minus 1 by divided by 1 plus theta x to the power n. Now we are going to find the Lagrange remainder. So in this question, we are going to find the Lagrange remainder of the n terms in the expansion of e to the power ax cos bx and e to the power ax sin bx and 1 plus x to the power m in power of x. So here we'll take what? Here we are taking here fx equal to e to the power ax cos bx. So if you differentiate this, there are two functions, so you have to differentiate this by product rule. So if I differentiate this one by product rules, first I will differentiate this. So if I differentiate this, we get eax. Then I have to differentiate again this. So if I differentiate ax with respect to x, I get nothing but a. So we get aeax, and cos bx I'm writing here plus. I've write the first function here, so eax. So if I differentiate cos, I get nothing but minus sine. So you get minus sine bx. Then I have to differentiate this bx. So if I differentiate bx, I get nothing but b. So we get here baex minus sine bx, which is if I take eax common, so we get here a cos bx minus b sine bx. So in place of a, I put as r cos theta, and in place of b, I put as r sine theta. Then what is r? So if I square and add this to equation, then I get r is equal to square root of a square plus b square. And if I divide this divide by this, I get theta equal to nothing but tan inverse b by a. Now this is the first order derivative. So if I put in place of a, you put r cos theta, in place of b, you put r sine theta. So from here you can take r common. So if I take r common, we get here r eax cos. By using this, if I take common r, we get cos theta cos bx minus sin theta sin bx. So that is nothing but cos bx plus theta. So we have here cos bx plus theta. So again, you differentiate this by product rule. So we have two functions. So r is constant. So if I differentiate ax, we get ax. Then I have to differentiate ax. So if I differentiate ax, I get nothing but a cos bx plus theta. Then here r is a constant. I'm writing this. So eax also we don't need to differentiate. Now I have to differentiate this. So if I differentiate cos, I get nothing but sine minus sine bx plus theta. So I have to after that I have to differentiate this. So if I differentiate this, I get b into 1 plus 0. So we have here b. So that we get, I can take common here r into e to the power ax. I take common. So I left with a cos bx plus theta minus b sin bx plus theta. I will substitute the value what we have taken, a as r cos theta and b as r sin theta. So we put this value, then I can take r common, so we get r squared eax. So if you use the form here, we get cos theta cos bx plus theta minus sin bx plus theta. So that is nothing but cos bx plus theta. That is nothing but bx plus 2 theta. So we get here bx plus 2 theta. So if we want to generalize this one, so we have here f double dash x. So we have here r squared eax cos bx plus 2 theta. So here we have f and x. So if I take n, here if it is 2, here we have r squared. So if it is n, it will be r to the power n. eax, so ax cos bx, so cos bx. But when it is 2, here we have 2 theta. So when it is n, it will be n theta. So we have r is nothing but a square plus b square to the power half n ex cos bx plus theta. Theta is not n theta, so theta is nothing but we have already got theta is equal to tan inverse b by a. So you put here tan inverse b by a. So we get here, you multiply 1 into n, we get n by 2. So we have a square plus b square n by 2 eax cos bx plus n tan inverse b by a. So we get here tan inverse b by a. So remainder in Lagrange form. So we are taking I xn by n factorial fn theta x. So xn by n factorial a square plus b square n by 2. E in place of theta, in place of x, wherever x is there, you put theta x. So we get e to the power a theta x cos bx b theta x plus n tan inverse b by a. So we get here n tan inverse b by a. So in the similar manner for this question also we proceed in the similar manner. So if you proceed in the similar manner, then we can find the remainder in Lagrange form. So this one also we have to do in the similar manner. You proceed in the similar manner, then we can find the remainder in Lagrange form. Thank you.